Imagine a massive rogue asteroid hurtling through space undetected on a collision course with Earth. It's the stuff of science fiction nightmares, but could it become reality? Are we, as a species, ready to face such a cosmic threat? Today we're diving into the science of rogue asteroids, the risks they pose, and whether humanity has what it takes to survive an impact. Buckle up, this is going to be a wild ride through the cosmos. Let's start with the basics. What exactly is a rogue asteroid? In simple terms, it's an asteroid that doesn't follow a predictable orbit, making it harder to track. Most asteroids in our solar system reside in the asteroid belt between Mars and Jupiter, orbiting the Sun in relatively stable paths. But rogue asteroids? They're the rebels. They can come from the outer reaches of the solar system, knocked loose by gravitational tugs from planets or other cosmic events. Some might even be interstellar visitors drifting from another star system entirely. These unpredictable space rocks are what keep astronomers up at night. Why should we care? Well, asteroids have a history of causing trouble. About 66 million years ago, a 10-kilometer-wide asteroid slammed into what's now the Yucatan Peninsula, creating the Chicxulub crater and triggering a mass extinction that wiped out the dinosaurs. Smaller impacts have happened more recently too. In 1908, the Tunguska event in Siberia flattened 2,000 square kilometers of forest when an asteroid or comet fragment exploded in the atmosphere. And in 2013, a 20-meter asteroid detonated over Chelyabinsk, Russia, injuring over 1,000 people with its shockwave. These events remind us that Earth isn't immune to cosmic collisions. So how likely is a catastrophic asteroid impact? The good news is that major impacts are rare. NASA estimates that an asteroid large enough to cause global devastation, say a kilometer or more in diameter, hits Earth roughly once every few million years. Smaller asteroids, those around 100 meters wide, are more common, striking every few thousand years. But here's the catch. Even a smaller asteroid could devastate a city or region. The 2013 Chelyabinsk meteor was only about the size of a 6-story building, yet it caused millions in damage. The bigger the rock, the worse the consequences. Now, let's talk detection. Are we even capable of spotting these cosmic threats in time? Thankfully, we've gotten pretty good at tracking near-Earth objects, or NEOs. Organizations like NASA's Planetary Defense Coordination Office and the European Space Agency run programs to monitor the skies. Telescopes like the Pan-STARRS and the upcoming Vera C. Rubin Observatory scan for potential threats, cataloging asteroids and comets that come within 50 million kilometers of Earth's orbit. As of now, we've identified over 30,000 NEOs with about 2,300 classified as potentially hazardous asteroids, those big enough and close enough to pose a risk. But here's the sobering truth. We haven't found them all. Smaller asteroids, especially those under 100 meters, can slip through the cracks. The Chelyabinsk meteor, for example, caught us completely by surprise because it came from the direction of the Sun, where telescopes struggle to see. Rogue asteroids with their unpredictable orbits are even trickier. Some might not be spotted until they're just days or weeks away from Earth. That's not a lot of time to prepare. So, what happens if we detect an asteroid on a collision course? Do we have a plan? The short answer is, kind of. Scientists and engineers have been brainstorming ways to deflect or destroy incoming asteroids. One idea is kinetic impactors. Think of it as playing cosmic billiards. You send a spacecraft to slam into the asteroid, nudging it off course. NASA tested this concept in 2022 with the DART mission, successfully altering the orbit of a harmless asteroid called Dimorphos. It worked, proving we can change an asteroid's path if we act early enough. Another option is the nuclear approach. Detonating a nuclear explosive near an asteroid could vaporize part of its surface, creating a jet of material that pushes it off course. It's not as crazy as it sounds. Scientists have run simulations showing this could work for larger asteroids if we have enough warning time. Other ideas include using lasers to heat and redirect smaller asteroids or deploying gravity tractors, spacecraft that hover near an asteroid, using their own gravity to slowly tug it off its path. But all these methods assume we have years, maybe decades of warning. What if an asteroid is discovered just months away? That's where things get dicey. Deflection takes time, and if the asteroid is too big or too close, we might not be able to stop it. In that case, the focus shifts to mitigation, evacuating impact zones, preparing for tsunamis or wildfires, and bracing for global effects like dust clouds that could cool the planet and disrupt agriculture. The economic and societal fallout could be catastrophic, even if the impact itself is localized. Are we ready? Honestly, we're not there yet. While NASA and other agencies have made huge strides in detection and deflection research, there are gaps. Funding for planetary defense is a fraction of what's spent on other priorities, and international coordination is still a work in progress. If a rogue asteroid were discovered tomorrow, we'd need a global effort to respond effectively, something that's easier said than done in a world full of political tensions. There's also the issue of public awareness. Most people don't think about asteroids until Hollywood makes a movie about them, but education and preparedness could save lives. Governments and organizations need to invest in better detection systems, like space-based telescopes that can spot asteroids coming from the sun's direction. We also need clearer protocols for who makes decisions if an impact is imminent and how to communicate with the public to avoid panic. The silver lining? Humanity is more capable than ever of tackling this threat. We have the technology, the brainpower, and the will to protect our planet. Projects like DART show we're taking this seriously, and advancements in AI and space exploration are opening new possibilities for early detection and deflection. But we can't get complacent. The universe is vast, and rogue asteroids are out there waiting in the dark. So, what's the takeaway? Rogue asteroid impacts are low-probability, high-consequence events. We've made incredible progress in understanding and preparing for them, but we're not fully ready. It's up to us, scientists, governments, and even regular people, to push for more resources, better technology, and global cooperation. The dinosaurs didn't see their asteroid coming. We have no excuse. Let's keep our eyes on the skies and make sure we're ready for whatever the cosmos throws our way.